What did you get? Yeah.
So we got NaF
NaF
plus H3PO4.
plus H3PO4 HF
Plus
Na3PO4. All right, this is not balanced, but what I do is look for driving force before balancing it. And so is there a driving force? Yeah. There's no precipitate. This is group 1, hydrogen. This is a group 1, sodium. So they don't precipitate. Then we look for acid. What did you get for acid? Phosphoric acid. To what acid on the products? What's the name of this? Sodium phosphate is not an acid. No. Acid has got to have hydrogen. There is an acid, it's HF. What's the name of that acid? Hydrofluoric. And so we're going from phosphoric to hydrofluoric. Well, which one's stronger? So we can look at the acid chart here. Here's phosphoric, here's hydrofluoric. So which one is a stronger acid? Phosphoric acid is stronger. It's not a strong acid, it's just stronger. SA just means stronger. It doesn't mean strong. And so it need not be strong. It just has to be stronger than this, which it is. And so all we need is one driving force. This is the driving force here. Since we have a driving force present, we should balance this. How can we balance it? We need 3 sodium fluorides and 3 HFs. So this is what we call the CE. Did someone get the IE for this?
I have a question. Are we going to have a chart like that to help us figure out if it's a stronger or weaker acid?
Yeah. For the test, you'll be given this very exact chart for this test. Yeah. Did somebody figure out the IE? No? So is this a strong acid? Is it a strong base? Is it a soluble salt? Yeah. So a soluble salt we break apart into what? 3 Na plus, 3 F minus. Good. Is this a strong acid? It's a stronger, but is it a strong acid? No. Is this a strong base? No. Is it a soluble salt? No. So just leave it alone. If it's not one of those, then don't do anything.
Sorry, can you repeat that one?
Is this a strong acid? One of the 7 that you memorized? No. Is it a strong base? No. Is it a soluble salt? No. So leave it alone. Is this a strong acid? No. Is it a strong base? No. Well, phosphate. Phosphate is borderline here, but it's on this side of hydroxide. So all these are strong. This one's weak. It's right at the border. It's not a strong acid. It's not a strong base. Is it a soluble salt? Yes. So we ionize it into what? 3 sodiums and a phosphate. And then we get rid of what doesn't change. On the left, going to the right. sodium, yeah. So we're going to get rid of the sodiums. Those didn't change. How about the fluoride? Did the fluoride change? Yeah, on the left it's fluoride, on the right it's hydrofluoric acid. Two different things. And so it looks like, and phosphoric acid did change. So it looks like the only thing that didn't is the sodium. So let's get rid of the sodium. So this is going to give us 3 fluorides plus H3PO4 yields 3HF plus a phosphate. That's what's reacting there. This particular reaction. All right, and the next example we're going to do is this sodium bicarbonate plus lithium phosphate. Okay, so we'll go through this one together. Sodiums are Na+. What's bicarbonate? HCO3 minus. And so look, +1 -1 is just 1-to-1 ratio. So it's NaHCO3, sodium bicarbonate. And then lithium, Li+, phosphate, PO4 3-. So what's the correct ratio of lithium to phosphate? Li 3 PO4. Li 3 PO4. And so all we're going to do is swap them now. Swap the anions. So what are we going to form? I'm going to take sodium and phosphate. So I'm going to be left with sodium phosphate. What's sodium phosphate, the correct formula? Na3PO4. And lithium bicarbonate. What's the correct formula for lithium bicarbonate? LiHCO3. So lithium with bicarbonate and sodium with phosphate. All right, before balancing this, let's just make sure there's a driving force. So do we see a precipitate? No. Sodium is group 1, so all sodium salts are soluble. Lithium is also group 1, and so all lithium salts are soluble. So soluble, soluble, it's not going to precipitate. And then we look for stronger acid to weaker acid. Well, nothing's really changed. We got bicarbonate here, we got bicarbonate there. No stronger acid to weaker acid. And then we look for gas formation. Does bicarbonate decompose like carbonic acid? It doesn't. We need the 2 hydrogens in a CO3. H2CO3 decomposes, HCO3 doesn't. So bicarbonate's stable, unless you have another H+. So HCO3- doesn't decompose. There's no driving force. No precipitate, no stronger acid, weaker acid, no gas formation, no driving force. If there's no driving force, then what we say is there's no reaction. NR means no reaction. No reaction. But the problem with this is that, are we considering all reaction types? No. How many reaction types are there? 3. There's metathesis, acid-base, and redox. So what I need to say here is that there's no reaction for metathesis. I need to check for acid-base, and I need to check for redox. So no reaction for metathesis, check. for acid base and or redox. Well, we did an acid-base reaction, the previous one, which is sulfuric acid and sodium hydroxide. That's an acid-base reaction, but we do them differently here. And so there's some overlap between metathesis and Bronsted acid-base. So let's talk about acid-base. Bronsted Lowry. For metathesis, you do complete reaction. So for example, H2SO4. H2SO4 has two acidic hydrogens. And so when we react that with sodium hydroxide, we react it with two sodium hydroxides to neutralize both those hydrogens. And so what we end up with is two waters plus sodium sulfate. For Bronsted, what we do is we just we do one hydrogen at a time. Only one H plus. This we call it transfer between the acid and base at a time. And so we do the reaction a little differently. So if I were to do the exact same reaction, H2SO4 plus sodium hydroxide, I would get this. I'd get the first hydrogen done. That leaves me with sodium hydrogen sulfate plus water. Liquid. And then the second hydrogen would have to be taken off in a second step. So I have the second hydrogen on there. Use the sodium hydroxide, and I'll make Na2SO4, and then the H will combine with the OH to make water. And so it's going to be in two steps here. So again, for metathesis, you just react it completely. For Bronsted, we'll react only one H plus at a time. So for phosphoric acid, in the previous example, before this one, we reacted all three hydrogens on there. So what are the steps for Bronsted? Step one, we get something called the inventory. And that is, we look for the major species present. And so if I have sodium hydrogen carbonate or sodium bicarbonate, I expect to find in this sodium ions and bicarbonate ions. Now, does the bicarbonate split apart? Does the hydrogen break off the bicarbonate? Actually, did we go on break? No? What do you want to go on break, or do you want to keep going? Break? Okay, let's take a break, sorry. Let's go on break.